Hello everyone. Welcome to the mini lecture on electromechanical control technology. Today, we will learn about debugging of stepper motors. Our lesson will cover the following topics. Through this lesson, I hope you can independently complete the debugging process for stepper motors, including initialization parameter settings, motor rotation tests, current and microstepping adjustments, in-motion trajectory optimization, ensuring both safety and efficiency during the debugging process. You should be able to identify and resolve common issues encountered during stepper motor debugging, such as the motor not rotating or uneven movement. Debugging a stepper motor is a complex and meticulous process that requires careful execution of each step and adjustments based on real-world conditions. With the correct debugging procedures and precautions, we can ensure that the stepper motor performs optimally in practical applications. Next, we will specifically learn the steps for debugging the stepper motor. 1. Preparations before debugging. 1. Understand the stepper motor and its driver. First, we need to understand the basic principles and characteristics of stepper motors, as well as the functions and parameters of their matching drivers. A stepper motor is an actuator that converts electrical pulse signals into angular or linear displacement, featuring high stepping precision and accurate positioning. The driver controls the operation of the stepper motor. By adjusting the driver's parameters, we can modify the motor's motion characteristics. 2. Check equipment and connections. Before starting the debugging process, we need to ensure that the connections between the stepper motor and driver are secure and reliable. Additionally, we must verify that the control signal lines and power supply lines are correctly connected. 2. Debugging steps. 1. Parameter initialization. On the control card or controller, we need to select the appropriate control mode and reset the PID parameters. Also, ensure that the enable signal is set to off by default when powering up the control card, and save this state. 2. Test motor rotation. Activate the enable signal for the stepper motor. At this point, the motor should rotate at a low speed, also known as zero drift. If the motor does not move or behaves abnormally, we need to check the settings and wiring of the enable signal. 3. Adjust current and microstepping. Next, we need to adjust the current and microstepping parameters for the stepper motor. The current setting should be reasonable, typically between 70% and 80% of the motor's rated current. The microstepping parameter determines the resolution and smoothness of the motor's movement, which can be adjusted based on actual requirements. 4. Test motion trajectory. Use tools like oscilloscopes to observe the motor's motion. Based on the test results, we can further adjust the control parameters to optimize the motor's motion trajectory and performance. 3. Debugging precautions. 1. Safety first. During the debugging process, ensure that the power supply is functioning correctly to avoid electric shock and other safety incidents. 2. Stable connections. Check that the connections between the stepper motor and driver are stable and reliable to prevent issues caused by looseness or damage. 3. Monitor temperature. During extended operation, we need to monitor the temperature of the stepper motor to ensure it does not overheat and cause damage. 4. Record data. Throughout the debugging process, record key parameters and data for subsequent analysis and optimization. With the continuous advancement of technology and the expansion of application fields, stepper motor debugging plays an increasingly important role in technological innovation and development. By debugging and studying the performance characteristics and behavior of stepper motors, We can provide strong support for the research and development of new products and improvements. Furthermore, the ongoing development and refinement of stepper motor debugging technology also promote advancements and innovations in automation and intelligent manufacturing. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.